Hello, students of mathematical studies. This is a video on using the half-angle formula for cosine to find sines and cosines of angles that are new to us, that are not on the original 16 from the unit circle. So, using the half-angle formula for cosine to find sine and cosine values for new angles on the unit circle. Yes, so we're going to use, for example, our example is going to be 5 pi over 8. And we're going to find the sine and cosine of 5 pi over 8. So, first off, the half-angle formula is that the cosine of half of an angle, and notice the notation here, we take some generic angle and we cut it in half. So there's a cosine of half of an angle is, and because this is generic, we don't know where we are, so we don't know if it's positive or negative, because cosines can be positive or negative. And this is the formula that we recall we derived once upon a time. And perhaps you remember the story of finding first the angle difference formula, turning it into an angle sum formula with that even and odd function business. That became a double angle formula, and working that one backwards is how we actually found this. A lot of 2's in it. So pretty much if you don't know what to write a 2. Every single thing in here has a 2. There's a 2 in this denominator here. There's a 2 in the denominator here. There's a 2 in front. There's a 2 coefficient. So if there's anywhere a 2 could be, there's a 2 there. Now you have this formula. Very important that your bar here is under the whole entire radical, and that the radical is not, there's no square root of 2 on the bottom here. That would be an improper fraction. This one is proper, it's got a natural number for a denominator. So, let's go ahead and find the cosine of 5 pi over 8. And if you're wondering what that is, pi over 8 would be a half of a 45-degree angle. It would be a 22.5-degree angle. This is 5 of those 22.5s. Where it is over here. It's in the second quadrant. There's the right angle, which is 4 pi over 8. One more of those, so it's over here. So take half of a 45-degree angle, add it to a right angle, and you have this obtuse angle in the second quadrant that we are trying to find the cosine value of. So we're trying to find how long this line segment is. So here we go. Plus or minus. You know what? I'm going to get rid of that plus or minus right now, because we just discussed where this angle is. It's in the second quadrant. Second quadrant angles have negative cosines. So this is no longer a gee, I don't know, is it positive or negative? We know it is negative. So we know where we are. So we've got that. Now we have 2 plus 2 times the cosine of 5 pi over 4. So if half the angle is 5 pi over 8, the whole angle is 5 pi over 4. And all this is over 2. Now we know the cosine of 5 pi over 4, because 5 pi over 4, let's consider the idea of the unit circle. There's 4 pi over 4. There's 2 pi over 4. That's 3 pi over 4. 5 pi over 4 is down here. 5 pi over 4 is the fourth quadrant angle, where cosines are negative. So, you've got negative radical 2 plus 2 times negative radical 2 over 2, all over 2. A lot of 2's here. What's nice about having so many 2's is that one of them is a coefficient and one of them is a denominator of the thing that coefficient is multiplying. So these two 2's are going to vanish. We've got a 2 plus negative radical 2, and plus negative is minus, so we are left with negative, the square root of the quantity, 2 minus radical 2, all over 2. And we have succeeded. I'm going to go ahead and pause this video now simply so it's not too big. We'll come back in a moment and do pi over 12, or one of the pi over 12s in just a little bit.